This lesson is about triangle inequality. The first rule is that in a triangle, the largest angle is across from the largest side. So if we were looking at this picture, this would be the largest side. So therefore, this is going to be the largest angle. And the opposite is true. This here is our smallest side. So this is going to be our smallest angle. Okay, let's take a look at some examples. So we need to list the sides from least, we need to list the angles from least to greatest. So to list the angles from least to greatest, we need to know the sides. So on this one, this is the smallest side. So therefore, this is going to be the smallest angle. Now we want the medium side. So here's the medium side. So this is going to be the medium angle. And last but not least, this is the largest side, so this is going to be the largest angle. We can do the same thing over here. OD is the smallest, so the smallest angle would be angle G, then followed by angle D, and then angle O. So given the sides, we can list the angles from least to greatest. Now we need to go backwards. Given the angles, we need to list the sides from least to greatest. So this right here is the smallest angle. Whoops. So this is going to be the smallest side. So AB will be listed first. Okay, we keep moving on. This is the medium angle. So this is the medium side. And last but not least, this would be the largest angle. So this would be the largest side. So over here, we'll do the same thing, but we're missing information. First, we have to figure out all the angles in a triangle. So we have to do 180 minus 58 minus 57. So we know this angle here is 55. Now that we know that, we know it's the smallest. So the smallest side would be DE, followed by DF, and then followed by FE. Okay. So in this one, they give us a picture. We need to list the sides from least to greatest. Well, to list the sides from least to greatest, we need to know the angle measures. To know the angle measures, we need to know the value of x. And in this problem, they've given us all these angles, and the angles of a triangle always add to 180. So to find x, we can say 5x plus 3 plus 3x minus 2 plus 2x plus 9 equals 180. So we'll combine like terms. 5 and 3 is 8. That's going to give you 10x. This is 1 plus 9 is 10 equals 180. So 10x equals 170. So x is 17. Now that we know that, we just use our calculator to plug it in to the different angles. Obviously, this is not all n. These should be O and P. Alright, so let's find the other angles. That would be 3 times 17 minus 2. So this angle would be 49. O would be 5 times 17 plus 3. So this is 88. And last but not least, we have 2 times 17 plus 9. So this angle would be 43. And now that we know the angles, we can list the sides from least to greatest. This is the smallest angle, so that is the smallest side. So we would have NO, followed by OP, followed by NP. There we go. Alright, this problem. Now they gave us information about the sides, and we want to list the angles from least to greatest. Well, if they've given us the angles, they add to 180, but the sides add to a different number each time, and that number that all the sides add to is the perimeter. So in this case, all the sides add to 76. So we're going to say 4x minus 7 plus 3x plus 8 plus x plus 11 equals 76. So in combined like terms, that's 7, 8x. this is 1 plus 11, which would be 12, equals 76. So we subtract 12. Oops. Okay. That would be 80, or 8x. We subtract 12 and we'll get 64, so x is 8. Now that we know x is 8, now we can find the length of each segment. So RS would be 4 times 8 minus 7, which would be 25. ST would be 3 times 8 plus 8, which would be 32. And lastly, we have 8 plus 11, which would be 19. Now this one doesn't have a picture to go with it, so we're just going to make a little sketch and call this RST, and then we can label. RS is 25, ST is 32, and RT is 19. So now that we have the picture, this is clearly the smallest side, so this is going to be the smallest angle. So that's angle S, followed by angle T, followed by angle R. And we're good. Okay, this one. List the angles from least to greatest. Well, to list the angles from least to greatest, we need to know the length of the side. And given two ordered pairs, to find the length of the side, in other words, the distance between the 2 points, we have to use the distance formula. So that is the square root of x2 minus x1 squared plus y2 minus y1 squared. So now we're going to plug it in and find the length of each side. So let's start with GH. GH would be x2 minus x1, so that's negative 5 minus negative 2 squared plus negative 8 minus 4 squared. Minus a negative is plus a positive, so we have negative 3 squared, which is positive 9. Negative 8 minus 4 is negative 12. Negative 12 squared is positive 144. And we get the square root of 153. Now, on these, okay, all we need to do at the end is compare them small to big. So there's absolutely no advantage of simplifying the radical, even if it's easy to simplify. Let's now find HI. So HI would be 6 minus negative 5 squared plus 10 minus negative 8 squared. Minus the negatives become plus a positive. So it's 11 squared, which is 121, plus 18 squared, which would be 324. We add these together, and we get 445. Alright, last but not least, GI. So we're going to go find GI, and GI would be 6 minus negative 2 plus 10 minus 4. Minus negative is plus a positive. 6 plus 2 is 8, so we have 8 squared, which is 64. 10 minus 4 is 6. 6 squared is 36. So we get the square root of 100. Which, yes, it simplifies, but again, you don't need to, because we just want to be able to compare them. We want to keep them all in the radical, so when we compare them, we're comparing the same thing. So I'm going to make a picture of GHI. GH is the square root of 153. HI is the square root of 445. And GI is the square root of 100. And now that we have the picture, it's easy to see that because this is the smallest side, this is going to be the smallest angle. And then next would be angle I, and then angle T. Alright. Next thing with triangle inequality. So these three sides make a triangle. So we have a rule that says the sum of any two sides of a triangle must be greater than the third side. Because given two sides, not all combinations will work. Let's look at this example. Pretend this side is 10, and this side is 5, and this side is 2. If I try to fold them together and make a triangle, they're just going to collapse on themselves. They're not actually going to meet up and form a triangle. So not any three numbers make a triangle. You have to see if the any two sides are greater than the third. So let's try this. So in example 1, I've got to try all the combinations. So I'm going to have 15 plus 12 is greater than 9. So I get 27 is greater than 9, which is true. Another combination. 12 plus 9 is greater than 15. 12 plus 9 is 21, which is definitely greater than 15. We're good. Last combination. 9 plus 15 is greater than 12. 9 plus 15 would be 24, which is greater than 12. So yes, that works. So yes, it's a triangle. Now, the reality is on these problems, you don't actually have to check all three situations. What you have to check is this one. You have to see if the two smallest are greater than the third. If that situation works, then everything else will work. If that one fails, there's no reason to go on. So, for this example, the two smallest would be 9 and 10. So I'll see if 9 and 10 are greater than 20. So I get 19 is greater than 20, which is false. It's not greater than. So we say no, it's not a triangle. Okay, pause the video and do example 3 and 4 on your own. Okay, this is what you got. On number 3, you got it was no because it wasn't greater, it was equal, and 4 is yes. Okay, number 5. Given 2 of the 3 sides of a triangle, write the compound inequality for the possible value of the third side. So given 2 sides, there's a whole series of numbers that work for that range for the third side. Okay? So if we have 2 sides of a triangle, we're trying to figure out what this third side is going to be, and depending on if it be real small or real big, depending. Problem is, this third side, we don't know if it's small, medium, or large. We have to do a little work. So we have to try the different situations. So let's say 14 plus x is greater than 10. So x is greater, if I subtract 14, than negative 4. One situation. Try another one. 14 plus 10 has to be greater than x. So I get 24 is greater than x. Okay, next situation. 10 plus x is greater than 14. So I get x is greater than 4. Alright, now that I've got my 3 pieces of information, now I have to write my final answer. We know in a triangle we cannot have a negative side. So this inequality, no good to us. So now we're just going to use the other one. And we're going to write it as a compound inequality. And when we do that, x goes in the middle. We have 2 less than symbols. The smaller number 4 goes on the left, and the bigger number 24 goes on the right. Okay, pause the video and do example 6 on your own. Okay, hopefully you got this. You tried out your different situations. One of them was negative. The other 2 work right as a compound inequality. Okay, from chapter 1, you should remember there must be less than symbols with a smaller number on the left and a bigger number on the right. Alright, example 7. Possible form a triangle with the given vertices. Well, to do that, we have to add the 2 smallest sides together and see if it's greater than the third. But first, we have to figure out the side length. And to do that, we have to use the good old distance formula again. Okay, so RS, x2 minus x1, so 3 minus 0 squared, plus 5 minus 0 squared. 3 minus 0 is 3, 3 squared is 9, 5 minus 0 is 5, 5 squared is 25, so we get the square root of 34. Now, in the end, we're going to have to add the 2 smallest. But to add we can't add radicals, so what we have to do is round and make it a decimal. And we have to round to the nearest hundredth. So put it in your calculator, and in your calculator, you're going to get 5.83. Now we need to do this again. Next one, ST. ST would be 5 minus 3 squared, plus 3 minus 5 squared. We get 2 squared, which is 4, negative 2 squared, which is also 4, and then we get the square root of 8. In your calculator, the square root of 8, 2.83. Okay, let's try this again for the last one. The last combination would be RT. x2 minus x1, so it's going to be 5 minus 0 squared. y2 minus y1 would be 3 minus 0 squared. So we get 25 plus 9, which is the square root of 34. And if you make that a decimal, obviously we're still going to get 5.83. So, to figure out the yes or no, this y is our work. We're going to check to see if the 2 smallest, which would be 2.83, and 5.83, see if it's greater than 5.83. Well, you don't have to work very hard to see that that is obviously true. Alright, pause the video, try example 8 on your own. Okay, hopefully this is what you got. You got your 3 numbers, and when you round to the nearest hundredth, it only works if you do nearest hundredth. You will see the 2 smallest are equal to the third, so therefore this one is a no, it does not work. Alright, last example type. So given the sides find all possible values for x.